Yeah, so hi everyone, welcome to my talk. I introduce HighLine for you. Let's have a video. What we are doing, we are focusing on microextrusion systems, various sizes. You see this, our mono. You can also look at the product itself on the other side of this, let's say, wall. We can intermittent extrude very small lines. Our core USP is to print down to less than 20 microns. We can print on top of each other. We can print in parallel, and this is the original idea, which you will see. Why is this the original idea? Because our founding idea is to improve the metallization on solar cells, as you can see here. And PV manufacturing is a highly scaled technology. Here the same thing as on bipolar plates for hydrogen. This replaces a PVD step. This is full layer coating where we extended our technology. And of course, this can also work on reel-to-reel. But first, let's go to the history of HighLine. We saw this exchangeable nozzle kit here. With this nozzle kit, you define your layout on the substrate. And as I said, we have the products in various sizes. So where are we from? We are from Freiburg. We have 20 employees, full-time equivalents. We have more than 20 employees, actually. And our key competence is design, production, and we are also very good in application and software control. We have our technical center, which is in the bottom floor of the building that you see here, with 400 square meters of application and production space. And application, we started with solar, now we also entered hydrogen, and we have requests from electronics, automotive, and others, as you will see throughout the talk. As Manuel said, our background is Fraunhofer ISE, Institute for Solar Energy Systems, where we started. Where we printed those very small lines down to 17 microns, later even 12 microns, with sintered silver pastes. And from there, we founded HighLine to actually not only print paste, but actually design a product that we can commercialize. And from this one product, a few were derived, and the technology was improved. We integrated with various partners. And that's where we are. We started the market entry this year, no, actually last year, with our product, which is parallel dispensing units. On the left-hand side, you see that. You can detach it from the tool with a very simple manual step. And then, for instance, for adhesives or for low temperature paste that need to be frozen, you can just directly put all the fluidic part in your freezer. Then in the middle, our cuckoo integration kit. The cuckoo, why is it cuckoo? Because the cuckoo is laying its eggs, not in its own nest, but into a nest of a parent bird. So what did we do? We put our automation into like a screen printer, which we want to replace, of course, with our technology. And then using all the things that the screen printer already has, meaning cell alignment, cell handling, and all this. And then making a dispensing unit out of it. And then, you think of nozzles, and everyone has a different nozzle design. Everyone, when you parallelize your technology, you want different spacing, different openings. And so we designed this nozzle kit, which can be exchanged just like a screen. Same amount of downtime of the machine, or even less. And then you just continue your production. So here you see it again, this print head. The exchangeable nozzle kit on the bottom, which will come in the following slide, with RFID interconnection and a quickly plug-and-play mode. All the electrical components are in this black unit, and all the fluidic parts are in the blue unit. Yeah, what did we achieve? You see this here. Very small line width, very important for a solar cell. And then we continued with full layer coating and also very small dot printing. Yeah, the nozzle unit, as I said, on the bottom of the print head, that